A very good morning, ladies and gentlemen, and welcome back to day 3 of Supercomputing Asia 2022. We will be commencing very shortly, but allow me to share with you some very important housekeeping announcements, especially for those of you who are just joining us for the very first time. Some of you right here at Suntech and a lot of you on the virtual world joining us. There will be concurrent sessions going on in this hall, in this very main hall in Suntech, as well as the adjoining 4 rooms on your left. You can access the program via your virtual event platform, as I've mentioned the past couple of days, by scanning the QR code at the back of your badges. Yep. You also have the ongoing exhibition. The ongoing exhibition is on your right. As you get out of this room, it's on your left, of course, and you've got ushers to take you there. Now, owing to prevailing safe distancing measures and safe measurements at hand, we will have specific timings in which each zone gets to go to this exhibition. The information can be seen in the banners outside of this ballroom. For our audience online, you will be able to access the various concurrent breakout tracks and the exhibition hall via the virtual lobby. To enjoy the fullest experience, of course, do ensure that your internet connection is nice and strong and good from where you're coming from. You will find the Q&A panel on the right of your SCA platform window. I say that nice and slow so that you know exactly where to navigate to on your screens. This is where you can raise your questions, ladies and gentlemen, should you have any thoughts during the talks. Meanwhile, do explore and visit the exhibition, of course, that's ongoing, and that can also be seen on your program, right? So, now, with that, ladies and gentlemen, I'd like to move on with the program. I'd like to thank all of you for joining us this morning. We've got distinguished guests and all of you right here and in the virtual world. Thank you for joining us for day 3 at the Supercomputing Asia Conference 2022. Welcome again, and this is proudly organized by the National Supercomputing Center Singapore, NSCC. I'm Ravi, and happy to be your host for this conference. Now, starting today's program, we'd like to have a presentation by Mr. Bill Mannel, who is the Vice President and General Manager of High Performance Computing HPC at Hewlett-Packard Enterprise. Ladies and gentlemen, please welcome Mr. Mannel.
Well, thank you, everyone, and thanks for being here for those that are here locally and also for those that are dialed in virtually as well. So I want to thank the show organizers, NSCC, for putting on this event, and it's good to be starting to get out and start to have more of a normal life. So hopefully this will be the start of a nice trend as we go forward. So first off, as you probably know, Mr. Al Geist spoke yesterday about some of the work that we've been doing with Oak Ridge National Labs around the first exascale machine. And we'll be doing a couple more of these as we go forward over the next year or so in the United States. However, we're now starting to look at what is beyond exascale. So what is the post-exascale generation, or what does that technology look like? And what are customers looking for? Are they looking for just bigger things that are like the exascale machines, or are they looking in particular for something different? So I'm going to talk a little bit about that this morning. So first off, there's a number of trends, and we've seen that at other talks today, during this particular conference. And one of those is heterogeneity. And it's kind of a tough word to pronounce, but basically what we see there is what we describe as the Cambrian explosion of different types of processors that are coming available in the market. So a lot of this Cambrian explosion is driven by the diversification of workloads. So we're seeing more specialty in workloads, and we're seeing that workloads themselves can need different types of processing. They're not always perfectly tuned for one particular processing element. And also, from a supply side perspective, we've all heard this, that CMOS limitations are starting to creep in with a lot of our more conventional type ways that we produce processing elements. So basically what we're seeing more and more of is achieving additional performance, maybe additional features through specialization. So right now, we keep count, there's probably about 50 to 60 startups that are working on specific ASICs that accelerate particular workflows. And so some of them are listed here, as you can see, and some of them have been attending here and presenting here as well. And so one of the things that's going forward is that it's going to be key with system architectures to take advantage of all this heterogeneity. And so we'll also need system software that makes it easier to engage and be proficient in this new set of accelerators that are out there. And this is also relative to the fact that typically when these new accelerators are created, the companies that are creating with them are challenged by the fact that they've got to create a chip, and then on the other hand, they've also got to create a development environment. So those are two things that are challenging for them to do. So one potential solution to that is to have more of a common development environment. So as new types of processors and specific ASICs come on board, they can take advantage of those particular capabilities very quickly. So not everyone has to build a new, if you will, compute and tuning and so forth and debugging environment. We also want system software itself that can quickly take advantage of all the new silicon that's out there. So that's another opportunity as well. And again, a programming environment that, as you are the programmer, can easily abstract to what you're trying to get done and result in workload productivity. So again, these are all things that we see are coming, and how do we want to better adapt to them and be able to use them as we go forward. So the other important thing is how do we bring all these processors together into a particular infrastructure. So here we have, you can see on the right-hand side, lots and lots of different types of processors that are being developed. Some of them are CPUs, some of them are GPUs, some of them are more custom chips, maybe AI chips, these sorts of things as well. And so we want to bring them together in a more heterogeneous system so that now you can have a system that can apply the right workloads to the most optimized processors at that time when the workloads are started up. You also want to have a development environment, as I mentioned, that allows you to compile your code for a particular ASIC, but also be able to very quickly compile or recompile that code for a different type of ASIC as well. So again, giving you that flexibility of being able to try different ASICs as you go forward. So again, as more and more of the silicon innovation is happening, we want to have a much more flexible and much more efficient way of taking advantage of it than we typically have today. And these HPC delivery models will embrace more federation. So in other words, that will allow you to take different types of even system architectures and bring them together into, let's say, one supercluster, if you will. So as we talk to a lot of customers about what they see as they go forward, these are some of the things that they told us. One, they're expecting big data to become even bigger. So more and more sensors out there, more and more simulations running at high speed, creating lots of data. So more and more data out there as well. Again, wider and deeper heterogeneity in terms of processing elements and in terms of workloads. There's going to be instruments. So in some cases, these can be widely distributed. So it could be across the campus, if you will. It could be across the whole country or even across the world. And you'll want to have those instruments available to a variety of different users and make that efficient as well. And also, there's going to be different expertise out there. So in some cases, you might have some specific expertise in one area around one type of processor and different expertise in another area, and you want them to be able to share data and also share compute capability. A lot of customers that we talk to are saying they want more open source capability, so much more of an open environment to allow them to take advantage of the flexibility of that and being able to even tweak and change some of that environment on their own. Also, when they start to work together, they want to have a more enterprise-like capability. So these are things like a single sign-on capability, being able to share data globally, and also being able to broker compute. So in other words, being able to use the compute. Now, being a member of a very large multi-global company, I'm lucky enough to enjoy that. I can take my laptop and fly from my Houston headquarters to Bangalore, for example. We have a very large site there, and pop up my laptop, and sure enough, I'm there. I can get it working, and I can get to all my data. This is what a lot of customers we talk to that are buying and using HPC systems want going forward. So some of the challenges in doing the things they want on the right-hand side of the slide. So you've got issues around the locality of data, security, sovereignty as well, managing data centers versus the core mission. So more and more customers are saying, hey, look, I'm really in this to find new pharmaceuticals, more therapeutics, not really to manage a data center. So we hear that a lot. A lot of customers use a more formal RFP process, or it might have an RFI followed by an RFP followed by a bid process, which can take a very long time and be actually pretty expensive in terms of resources. These are resources that aren't doing research, for example. They're just analyzing different responses to their RFP. And the RFP processes can be very inflexible. So in other words, they can take a lot of time, and you end up having to make early choices without really understanding what might be available in the future. So maybe 2 years when you get your machine, you're wishing, well, I wish I had that kind of processor in there, or maybe a few of this kind of processor instead. Finally, lots of dusty decks. So this is where you've got lots of code that's still being used effectively, but no one is really left that knows how to use it. So lots and lots of Fortran out there, even though we said Fortran was supposed to go away many years ago. And also attracting skilled people. And for some of our customers in the U.S., this could mean they have to have some citizenship. And that's the same with any country around the world. In some cases, if it's government or intelligence or Department of Defense type applications, they got to have some skilled people that are particular citizens of the country they're in. And this enterprise-like experience does come with limitations. Here we go. And so these are some of the answers to that as well that we see. So here's some more limitations. Again, this is with the current exascale system. So generally they're constrained with a relatively rigid environment. So typically they're a big cluster that's very homogeneous as opposed to heterogeneous. They've got management execution is relatively similar to what they've been doing for many years, so there's not a lot of changes there. They tend to use a batch job scheduler, and a lot of the jobs are more MPI type jobs, not necessarily new type jobs. Finally, they tend to have a shared file system. That's how they share data between different processing elements. That may or may not be the best way to do it going forward. Finally, from a performance standpoint, they have performance optimized networking. And finally, they tend to, again, have long procurement cycles, which can be as long as 5 years to bring on the types of technology they want to bring on. However, on the right-hand side of the slide, you see this is what the post-exascale world will look like. So scientists want more flexibility, as we talked about before, going beyond just the typical MPI jobs to be able to do different types of workloads, different types of compute paradigms, maybe mix different kind of paradigms within one particular workload. The data-driven science with AI and ML typically has different needs for compute and for storage, and a lot of times, again, you want to blend those together. Compute heterogeneity is going mainstream. So again, as I mentioned previously, lots of different processors. How can we all use them going forward? And the procurement cycle should be getting shorter. That way you can make a quick decision and say, hey, look, that processor looks really interesting to my workload. How can I get some of that in very quickly into my data center, if you will? So Dr. Pierce, a couple days ago, as part of the Square Kilometer Array, really had a good example of where a lot of this kind of environment is going to go. Here, in this case, you've got, again, two large instruments, as I mentioned before. You've got one in Western Australia, you've got one in South Africa. Then you've got a variety of compute resources all over the world. And some of those compute resources are attached to certain expertise as well. You've got certain scientists in certain countries that are looking at different parts of the universe as they utilize a square kilometer array. So a great example, and of course you've got data, you've got applications crossing international boundaries. So that's always a challenge as well. So this is a great example of what we expect to have in a lot more types of environment going forward. Oops, I'm not going to do the video. So this was the technology probably about 10 years ago. And not to say anything bad about it, but that's just the way it was. It was typically a portal. You uploaded your data, you uploaded your application if you had to, unless it was available somewhere, and then you chose whatever solution you wanted to run on. And this was the Exceed application or portal, if you will, that was part of the National Science Foundation in the United States. And so the government actually funded a number of different types of computing capabilities at different centers around the United States, whether you were at Pittsburgh Supercomputing, whether you were at San Diego Supercomputing. Typically, the National Science Foundation would fund to allow for that heterogeneity that I talked about before. Now, the problem with Exceed was the fact that it was really a procurement base, so it was not very flexible. So once the procurements were done, then you had to wait till more money became available before you could get additional types of capabilities. The other thing is the technology stales over time. So you don't have that way to turn technology very quickly to make that available to the users at the time. And again, you're limited by the government funding availability. So in some cases, government funding goes up and down. You won't have that level of funding that you might want to do to take advantage of those latest type technologies that are out there. And so, again, this is our vision of the next big step. So we put the Frontier, which is our current exascale machine that we're working on with Oak Ridge National Lab, on the right-hand side as sort of the typical exascale-based system. And then on the left-hand side, you see a whole host of different types of instruments. This is just not anything specific, just an example of lots of instruments that are not necessarily in the same place. Maybe they're in the same campus, maybe they're in the same country, or they may be scattered around the world. And you want to be able to use those instruments. Now, in some cases, you'll want to actually do some work on the edge, that is nearby where the instruments themselves are, because a lot of the data that comes in through those instruments might not really be useful for what your particular task is. So in some cases, I've heard that only maybe 1% to 5% of the data might be interesting. So you don't want to bring all that data across a potentially global fabric to go and throw most of it away. So let's process that data on the edge with some relatively powerful capabilities that can be made available on the edge. And you have an edge software stack associated with that as well, which would have some important elements because the edge, again, is more hazardous than typically a data center might be because it's on the edge, right? So you got to consider other things as you go forward. And so there's a degree of edge compute there, which can be, again, bring in a variety of different compute elements, maybe FPGAs because you're doing signal processing, maybe GPUs because you're doing visual processing, maybe more standard processors. And you got to worry about uploading the data as well. Maybe you upload it through a more wired-based fabric. Maybe it's through Wi-Fi, so you have more flexibility that way and easy startup. So you got to worry about those. And then you bring it through to the main computer where you can do your simulations, you can train your models, and then basically send the trained models back out along the fabric to the instruments to help you gather the next round of data, maybe with greater accuracy as you go forward. So again, in this example, you've got this idea of more orchestrated, optimized, AI-driven scientific discovery. So with much less limitations than we see today. So again, this is one of the visions we see as we go forward. Okay. There we go. And so after this, where are we heading just from a virtual standpoint? So again, when you look at things, we've got exascale capability. We're bringing it on board. We're able to get that today. And we'll see more and more exascale machines over the next few years or so, and even 2 and 3 time exaflops as well. We're going to again have this workloads diversification. So new workloads are coming on. We'll want to use workloads together in different ways as we go forward as well. Again, I talked a lot about this compute heterogeneity, so having different types of processing elements, different types of processing that would be available. Data sovereignty, more and more of an issue, right? So we want to share the data, but we have to be careful with that. And in some cases, we only share the results as opposed to the actual data. So you upload the weights of a trained model, a trained AI model, as opposed to the actual data itself, because it could have some privacy concerns if it's healthcare data. It could have some national security concerns if it's more security-related data. And so what this leads to is what we call the Internet of Workflows. So in other words, instead of the Internet of Things, we have the Internet of Workflows, which allows a variety of different workflows to basically migrate around the world in this case and find essentially the best home for them at this point in time. So that might, at a certain period of time, that might be a compute resource in Western Australia, or it could be a compute resource in Chicago in the United States, depending upon the workload and the availability of resources out there. So basically, the Internet of Workflows would allow us to go from edge to exascale, as we've talked about. So again, being able to process some of that data on the edge, make some decisions there, and then bring back the big work for the big machines as you go forward, and being able to pick those. You would have a democratization of parallel runtime environments. So again, allowing a user to be able to take advantage of a variety of different compute elements without having to do a lot of relatively time-consuming and resource-intensive porting and tuning to different types of architectures. You'd also have performance portability. So in other words, you could be able to move a particular workflow or a code from one type of architecture to another, and not having to go through that process of getting back the performance that you lost as you move to a different type of architecture. Certainly, having a secure networking foundation is going to be important, because this is both a quality of service as well as an IP protection, intellectual property protection issue as well. And something that allows for silicon innovation. So I talked a little bit about this before, where more vendors can participate, because it's a lot easier to get their silicon up into this Internet of Workflows. So they don't have the lift that they do today of having developed the chip and then also develop the development environment and develop the runtime environment to make it all successful. And finally, what we end up here is with a worldwide data web as we go forward. So it allows us to exchange data easily, safely, obeying all the governance that is necessary. And also hybrid execution pipeline. So this means that in a one particular machine, you can actually have different types of execution. So for example, being able to mix AI with high performance computing type, or more common modeling and simulation type workloads. And finally, it's open. You're in control. You can select what kind of elements you want and take advantage of whatever is best for your workload, depending upon where you are. So again, this is our vision, our post-exascale vision as we go forward. And basically, this is a rebirth of the internet that we had before, where the internet suddenly gave us access to all this data that we didn't have, but in this case, it gives us access to our workloads and allows us to accelerate new insights by having all this access and availability. So again, thank you. This was our vision of the post-exascale world. So at this point in time, I have the pleasure of actually interviewing our chairman and CEO, Antonio Neri, before I came to this event, to talk a little bit about the importance of high-performance computing, the importance to the Asia market itself. So I'd like to present that to you now, if I could. If you could please roll the video. We're at Supercomputing Asia with Antonio Neri, the CEO of Hewlett-Packard Enterprise. Antonio, thanks for being with us today.
Thanks for having me.
Can you talk to us a little bit about how important supercomputing or high-performance computing is to you and to Hewlett-Packard Enterprise?
Well, HPC and AI is a very, very important business for the company. It's very, very strategic and core to our strategy going forward to become the edge-to-cloud company. As we think about the progress we have made, HPC has a unique set of assets that differentiate us in the marketplace. Whether it's the system side, whether it's the silicon side or the software side, we have a complete integrated stack to deliver AI at scale. And you can see now the results of that through both organic and inorganic approaches, which obviously the latest acquisition was the Cray supercomputer, which added a lot to what was already a differentiated portfolio. And we think about the deployments we're doing for customers, not only in the US, but for Asia. It's just amazing to see the progress we have made. But listen, we live in a digital economy. Data is the most precious asset that customers have today, and they need to mine that insight at the pace we haven't seen before. And HPC and AI will play a huge role going forward.
And we've had a number of customers we're working with in Asia, such as NSTDA in Thailand, NSCC in Singapore here, and also Palsy in Australia, and a number of other defense-oriented sites. Can you talk a little bit about how important Asia is to HPE?
Well, first of all, I'm really proud of those deployments. I think, those are customers in a very, diverse region like Asia are relying on us to accelerate what we call the new age of insights. So super, super proud to work with those customers. But Asia is at the center of this global economy. It's not just China, by the way, it's all the countries around Asia. And I believe over the next decade or so, Asia will become probably, as a whole, the largest economy in the world. And therefore, as we think about this digital economy, data is going to play even a more greater strategic role. And we believe Hewlett-Packard Enterprise can power those economies, can extract the value of the data, and be very strategic in everything we do.
One of the big stories this year is some of the challenges we're having around supply chain. Can you talk a little bit about that and what HPE is doing?
Well, we are seeing tremendous demand. As we think about the last few quarters, Hewlett-Packard Enterprise has delivered 20+% order growth every single quarter. And that's a good news. However, because of the pandemic, there was clearly a dislocation in the supply chain. Capital infusion stopped at the beginning of the pandemic. And when you think about the demand uptick plus the capacity available, we actually got caught in the worst cycle. And demand is everywhere. It's not just for HPC, it's for data, mining, for compute, for the edge. And so what we're seeing now is the recovery process, which actually takes several quarters. New capacity is coming online, new fabs are becoming available. But the reality, we're going to experience this throughout the second half of 2022, and things should get much, much better, definitely by the beginning of 2023.
Great. Yeah, looking forward to the things getting better, certainly. AI is a big part of the market. Can you talk a little bit more about things that HPE is doing for AI?
Yeah. So first of all, we are consolidating all our assets into one integrated kind of business approach, which obviously allows us to innovate at scale, but also bring to market much faster, the type of innovation we're looking around AI and deep learning, and as well as machine learning. So we're making both organic and inorganic investment, but also through the partnership ecosystem with our Pathfinder program. Mm-hmm. So as I think about, the next few months and quarters and years to come, HPE and HPC and AI as a segment will play a huge strategic role for us as a company, but we are looking forward to become even more relevant as customers go through this digital transformation journey, which, by the way, data-first modernization is what they need to do. And therefore, this system scale are so essential to be successful as we look into the future.
And certainly with some of the skills gaps we see, AI is going to be an important part of being able to analyze that data.
Customers don't have all the skill sets. Definitely there is a war of talent out there for talent, which obviously is becoming a challenge for everyone to hire the right people. But I think our approach to provide out-of-box, ready-to-deploy AI solutions is a differentiated approach. So you don't have to have those a PhD, in data science or, AI programmers, that ultimately we can provide, the data in a way that customers can really extract the value much faster.
Any closing remarks or recommendations you have for the people here attending the conference?
Well, actually, it's great to see people back at conferences. Obviously, the HPC conference is a very, very strategic conference because people see the future, right? So is where the most advancements take place, where the leading innovations get deployed. And so I hope you see that our company is on the forefront of this exciting and massive transformation we see around data and data analytics and AI. And we look forward to gather your feedback because obviously we like to make sure that your input is included in our innovation roadmap as we look into the future.
All right. Well, thank you very much, Antonio.
Well,
appreciate your time.
Enjoy the conference.
Thank you.